This problem involves a man being pulled up a cliff by use of a pulley system and his older brother. To solve this problem for both the tension force in the string and the acceleration, we first must draw our free body diagrams. The free body diagram for the older brother would look something like this. The force due to gravity is acting down on him, with a normal force acting up. In the problem, it tells us that there's an applied force of 800 newtons pushing him forward, and we know that there's a resistive force from the tension pulling him back to the right from his brother hanging off the cliff. For the brother, our free body diagram would include the force of tension as well as the force due to gravity. Because the brothers are attached by one single strand, we know that the tension force is going to be equal in both free body diagrams. The second step is to draw our net force equation. Because the older brother is accelerating in the x direction, we are going to write a net force equation for the x direction, and it'll look something like this. Sigma F equals Fa and Ft. Now we have to decide which of those forces is the positive force and which force is the negative force. Because we're using a pulley, we need to use the pulley convention. So anything that goes clockwise around the pulley is going to be positive, and anything that goes counterclockwise around the pulley is going to be negative. So if we look at the force applied, he is walking this way, and that would pull the pulley in the negative direction. So Fa is negative, which makes Ft positive. We have Ft minus Fa. For the younger brother, we simply have the tension force and the force due to gravity. This is the direction that he's accelerating in, so we're going to write our net force equation for the y direction. And that's going to be equal to, well, these two forces added together, including their directions. So which one's positive, which one's negative? The tension force of the string acting up goes around the pulley in the counterclockwise direction. So our tension force is negative, which makes our force due to gravity positive. So I'll write Fg minus Ft. Okay, so now we need to use our two equations as well as Newton's second law, which if you remember is sigma F equals ma, to calculate both the acceleration and the tension force acting on the men. So over here, instead of sigma F, I'm going to write ma equals Ft minus Fa. And then this equation will be ma equals Fg minus Ft. The basis of our physics is completed now, and we simply need to substitute in some numbers. The mass of our older brother is 89 kilograms times an acceleration that we don't yet know, and that's going to equal the tension force, which we don't know, minus the applied force, which we were told in the problem is 800 newtons. For the younger brother, the mass is 55 kilograms times the acceleration, and that equals Fg. If you recall, Fg is the force due to gravity, or in other words, weight. To find weight, we use the equation Fg equals mg, where Fg will be 55 times 9.8. By multiplying these two numbers together, we find that the weight of the younger brother is 539 newtons. So I can use this number in my equation, 539 minus Ft. I now have a system of equations that I need to use some algebra to solve for. My unknowns are Ft and A in each equation. I have two equations, so I'm good to go. So the first thing I'll do is isolate one of the variables in one of the equations. In this case, I'm going to isolate Ft. So I'm going to add 800 to each side, so that I end up with 89A plus 800 equals Ft. So now, instead of having Ft in this equation, I can actually substitute this entire thing in for Ft. So we're going to rewrite this equation. It will be 55A equals 539 minus all of FT, which is 89A plus 800. Notice that this is in parentheses. I have to subtract the entire thing. So when I rewrite this equation to simplify, I get minus 89A minus 800. The only variable left in this equation is the acceleration, so I can now combine like terms and solve for the acceleration. To solve for acceleration, I'm now going to divide both sides by 144, and I get that my acceleration is 1.81 meters per second squared. Because the two men are attached, that is the acceleration for both of them, and I can use this acceleration in my tension force equation to solve for the tension force. So 89 times, and this number is actually negative. Do not forget that negative sign. And we get a tension force of 638.69 newtons.